Today for assignment 1, to solve the linear problem below 100% accuracy, I have chosen the perfect perception training rather than Herbian to solve the top to bottom problem. So first of all, we have given the random value for top to bottom for x1, x2 and x3. Other all for example, for the t value, we can assume the value as per stated. So for the sum value, we have to make x1 times w2 plus x2 times w2 plus x3 times w3. In this equation, we can solve the value for the sum. And for the y value, we can see the theta, whereas the theta value for the sum, which is greater than the theta value, will be given the y as 1, or else it will state as 0. So for example, as you can see here, the value is 0.8, which is greater than 0.1, so the value of y is 1. So for the weight value, we can find the new weight through the equation of old weight plus learning rate times with x value, which is from either 1 to 6, times with t minus y. So for the default value here, the old one, we have filled out with this value, and through the equation we can find the new value here. For the new bias, we have made the old bias plus learning rate times with t minus y, so we can get the new bias value here. Since the equation all plus b, we can get the new weighted sum through the equation, whereas we have to take the bottom value here. So here is the new value, and from the weighted sum, we can find the y prime, through which the sum have to be greater than theta, where is the y prime stated as 1, or else it will be 0. So to visualize the decision of boundary plot, I have taken the equation here and make the equation here greater than the theta to find the value of x3 through the x1 and x2. So the x1 and x2, I have put the default value here to find the new value for x3. So now I'm going to show you the MATLAB where the graph is plotted. So here is the MATLAB coding, whereas before this we have seen the values, right? So we have to put all these values here to see the graph, and here is the plotted graph. So we can see here the negative gradient line plotted here. So the line which separates the two area here represents the section A and B. That's all. Thank you.
Good morning to my lecturer Dr. Rafida and my fellow friends. Today I am going to explain how to solve linear problem accuracy with 100% accuracy by using PERCEPTRON training for bottom to top. First of all, in this table we can see that the value for x1, x2 and x3 is given by default. Therefore, for the sum, we will be using this value to calculate it. The formula is x1 w1 plus x2 w2 plus x3 w3 plus bias equals to s. For the t value, we will assume it. The next is for y value, we will be calculate by the sum more than or equal theta, y equals to 1, else it will be 0. So for the following w1, w2 and w3 with bias The value in the blue color box is, we assume, our own self. The rest of the values in all the green color box, we will calculate it by Wn formula, that is Wn equals to Wo plus n x1 bracket t minus y. By that we can get the following values for W1, W2 and W3. For the bias, the formula is Bn equals to B0 plus n bracket t minus y. So next is we going to see the weighted sum. For the weighted sum, we will take the last row of the values, that is 0.6, negative 0.4, negative 0.4 and also bias negative 1.2 to get all the values for the weighted sum by using these values. Since x1 w1 plus x2 w2 plus x3 w3 plus bias, so the formula for weighted sum is x1 with the value that we take. Next is y prime, same as the y, the sum of the weighted sum more than beta theta y equals to 1, else it will be 0. So now I am going to show the table for the bottom to top. For the values x1, x2 and x3, I follow this formula w1 x1 plus w2 x2 plus w3 x3 plus beta more than or equal theta. So we will get for each one values by using this formula. Next is I am going to explain the coding that I used to code the values in the MATLAB. For the x, the values are negative 3, negative 2, negative 1, 0, 1, 2, 3 with the following 6 of the x1 values 0, 0, 0, 0, 0, 0. For the y, same as the x values, but the values for the y is different. It is 0, 1, 0, 1, 1, 0. The next is z. The z values are negative 7, negative 6.5, negative 6, negative 5.5, negative 5, negative 4.5, negative 4, negative 0, 0, 1, 1, 0, 1 with the scatters 3 for the x, y and z. For each one we will be label it as x1 axis, for y x2 axis, for z x3 axis. For the title 3D scatter plot perception, and the outcome will be like these graphs. And this is the outcome for the coding that I have coded in the MATLAB. And this is the line of the gradient. There are each dotted with the different values, and this is the section A and the section B. For each one dotted, the x, y, z values are different. For first dot, the x is negative 2, y negative 2, z negative 6.5. For the second dotted, x negative 1, y negative 1 and z negative 6. For the third, x 0, y 0 and z negative 5.5. For the fourth, x1, y1 and z negative 5 with the fifth dot is x2, y2 and z negative 4.5, and the last dot of the gradient line is x3, y3 and z negative 4.
A very good day, doctor. My name is Navindran, and I'm going to explain about the ADALINE. ADALINE is an adaptive linear element, which is a single neuron model that uses a linear activation function. Now I'm going to demonstrate on how we're going to do ADALINE using Excel software. First, we're going to use the data given x1, x2, x3, which is shown here. We set the target 0 for class A, and for B is all 1. And then we set the learning rate to 0.7. We use a random value for initial or starting value, like for W1 is 1, W2 1, W3 1, and bias is 0. Now I'm going to explain how we got this value. For sum, we use this formula, which is x1 times w1, which is this value, is times with this value, plus with x2 times with w2, and x3 times with w3, and then plus b to get the value s, which is sum. And same goes to all the row. We can obtain the answer from using this solution or formula. For W1, we can use this formula, which is we use the initial value plus with the n, which is 0.7, times with the x1. For W1, the first row, we use this x1 first row, and then times with t minus with s, which is t minus with the sum. We also can use this value to replace the formula t minus s. We use this formula for all the w1, w2, w3. You can get all the answer here. For bias, we use this formula, which is b initial plus with n, which is 0.7, times with t minus sum. B initial is 0 plus n 0.7 times with 0. Okay, to get this weighted sum, here's the formula we used, which is x1 times with w1 plus x2 times with w2 plus x3 times with w3 plus b. We used for example, we used a random row answer for solution for this. After that, when we get the values, all the values, we form the table which is given to find x3, and the formula is here. We use this formula to calculate the value of x3. To find x3, we times w1 with x1, which is w1 from here to x1, and plus with w2 x2 plus with w3 x3 plus with b to get value of x3. We use that formula and bring out the x3 out, and we simplify the solution so that we can get the value by subbing the value of x1 and w1 in to find the value x3. For the ADALINE training rule, bottom to top, there's a small changes in the target, where the class A, the target is set to 1, and for the class B, the target is set to 0. The x1, x2, x3 will still remain the same, and first we need to find the w1, w2, and w3. We use the same method above for top to bottom, the formula, and we apply here. After that, we have to find the value for sum. Use x1 times w1 plus x2 times w2 plus x3 times w3 plus bias. You can get the value for s. And then we have to find a value for weighted sum. We use the same method, which is x1 times w1 plus with x2 times w2 plus with x3 times w3 plus b to find the weighted sum. After we collect the data, we need to find the value of x3. We use the same step, which is we use this formula w1 times x1 plus w2 times x2 plus w3 times x3 plus b. We take out the x3 out so that we can simplify the formula, so that we can use this data collected x1 x2, so we can sub in to get the value of x3.
So now I'm going to show you how the boundary plot graph is plotted. So from the ADALINE bottom to top value, we have put the values all over here for plotting the graphs. So all the x values are putting here, x1, x2 values and x3 values. So here is the plotted graphs. From here we can see that the negative gradient line is plotted here. So if we highlighted all the points, we can see here all the section A and B items are plotted here. So here is the values of the section A and section B respectively, which shows the 100% accuracy bounded. So now is the top to bottom part of ADALINE. So same as before, all the x1, x2 and x3 parts are plotted here. So the result graph is like this. So as usual, if we put the positive gradient line, we can see here there is the value of class A and class B are shattered here. So that's all. Thank you.